Hello and welcome to this demo of EMC XtremIO integrating with Microsoft ODX and Unmap. So what is ODX and why is it so important? When you think about data, data is dynamic, it is fluid. We keep transferring files from one place to another. For example, in the use case of a file server, we'll copy files from one folder to another. One PC or one server will try to copy files from one drive to another drive. In a SQL Server environments, we'll try to do a backup of the same clone's SQL database file to a storage device. In a virtualized environments, it's especially crucial because we are moving VMs, or should I say their VHD files, from one data store to another. We deploy a lot of VM from the same template, for example, in the use case of VDI, but also in the generic VSI use cases. And traditional data movement consumes a lot of resources. It needs to start read blocks from the storage, then it needs to copy the files over TCP/IP from one host to another, and then it needs to write the block to the target volume array. So how does ODX work really? Well, it's built into Windows Server 2012 and it's automatically invoked. So let's examine the following diagram. Let's say that the left server is the source file server. It needs to send a query to the destination server, whether it's supporting the ODX capability. And if the destination server acknowledges with a yes, then the source server will then do an offload of the read, and it will pass the token of the ODX support to the destination server. And then what's actually going to happen behind the scenes is that the storage array is actually going to do the file copy itself. No involvement of the host. They will acknowledge the file's movement and it will look as if they are doing the file copy themselves, but it's really the storage array in the background that does the copy itself. That results in a much more efficient copy. In many cases it's much faster, but not only faster, it doesn't consume as much as CPU, memory and network resources from the source server to the destination server. We're going to watch a demo in a second, and I'm actually going to use some registry keys to disable and enable ODX, and those will be the registry keys that I'm going to enable and disable in order to examine how does it work before ODX and how does it work with ODX that now XtremIO support. So let's jump to the demo environment. So what we have here is a single X brick running a Xios 4.0, and as you can see right now the array doesn't do too much. We have two volumes, one known as source ODX and one called destination ODX. Both of them are mapped into the same physical Windows Server 2012 R2 server. And as you can see, we have around 40 gig of logical capacity that is being consumed on the Windows physical server. And if we go back to the actual Windows Server itself, we can see that this is where the files are actually hosted. We've got two volumes, which are the equivalent to the volume that we saw on the XtremIO array. The D drive that has 40 gig worth of files resided into it, and the E drive that is it's completely blank, and this is going to be the destination volume where we're actually going to copy those files into. So by default ODX is on if the underlying array is supporting it. However, for the sake of the demo, I disable it, and this is the registry key that I've used and changed its value to 1, which means that ODX is now disabled. So what we're going to do now is going to go to the D drive and actually select all the files that we want to copy, and the moment that the copy will start, I will also start the free stopwatch timer, so we're going to see exactly how long it took. So, paste the files, paste, and start their stopwatch utility. Let's look how long it takes. We can also see the megabyte per second. That's also going to be very important when we're going to compare it with ODX on. As you can see, there is a lot of IOPS working at the XtremIO array. You can see exactly how much IOPS is being pushed. Pale blue means read, dark blue means write, and that's exactly what we expect because we copied a lot of files from the source volume to the destination volume. 40 gig worth of files. So far we have around almost 40 seconds passed. and we are literally just now about copying 50% of the data. So let's give it a couple of more seconds before it's finishing the copy itself. You can also see that the logical capacity is being increased. That is expected because we are literally just copying the same data. So from a physical perspective, no additional capacity will be consumed, but because we are copying the same data, the logical capacity will be doubled. That's the beauty of the inline deduplication within the XtremIO array. So the copy is still taking place. About 1 minute and 20 seconds, still going on. Couple of more seconds, it will finish. And again, this is where ODX is actually disabled. So we're just about done now. So it took us 1 minute and about 36 seconds to do the copy without ODX. The next step, what we're going to do is we are actually going to enable ODX, following by rebooting the server, because this type of parameter requires the server to be restarted. So that's exactly what we're going to do now. Change the registry value to 0 and then reboot the actual server. Okay, and I'm going to resume the demo when the server is going to be up and running again. Okay, the next part is to copy those files again where ODX is enabled. I've already deleted the files from the E drive just for the sake of the comparison, so it's exactly the logical capacity where it was before we started with the file copying. I've enabled the registry settings of ODX, enabled them, changed the value to 1 and rebooted the server. So let's now again select all the files that we want to copy them to the E drive. Again, both the D drive and the E drive reside on the same XtremIO array. ODX is enabled, paste them, start the timer. Let's see how long it's going to take. As you can see, the bandwidth itself is around almost 3 times faster, but the bandwidth itself doesn't tell a full story. It's really the time that it takes to copy those files. Very, very quick. It's all a backup operation, hence we don't see the values here. And in total it took us 18 seconds, let's say even 19 seconds, which are far, far quicker than what it was where ODX was disabled. Thank you. In the next part of the demo, we are going to demonstrate how EMC XtremIO integrates into Windows Server 2012 and 2012 R2 automated unmap command. So in order to understand the why, it's really important to understand what is the real benefit of automated unmap. With a Windows Server or even a Windows desktop, there is always a lot of empty brackets storage, which means files that we deleted or even VMs that we may have deleted. And it's really important to make the storage array more efficient because we want the capacity that we just deleted from the host level to return to the underlying storage array. And of course, XtremIO supports unmap. How does it work? So it's a feature that is built into Windows Server 2012 and 2012 R2. It does a SCSI inquiry on the LAN level to see if it is supported from the underlying array, and it's automatically invoked by whether you delete a file, which will generate an unmap operation. It can run as a background operation task or as a scheduled task through the optimized drive setting, meaning defragment your drive. And it also works when you format volume within Windows Server. So how does it look? Let's assume this is our XtremIO storage array, and it is thinly provisioned by its nature. It's always thinly provisioned. And I've just deleted a file. Well, then Windows issued an unmap command to the XtremIO array, and XtremIO array will start generating this backup process operation. It's also very important to understand that this feature is also supported for Windows Server Hyper-V. So for example, if I deleted a VM or even deleted a file from within a VM running under Windows Hyper-V, unmap will work again automatically. So that's very, very beneficial because the entire process is automated. Okay, so let's jump into the demo. Let's see how it works in real time. So here I have Windows Server 2012 R2, and I've got some files on the D drive and on the E drive, and what we're going to do is just delete the files from within the E drive. Notice that we have a dedupe of 2 to 1 because the files that are on the E drive are exactly the same replica as the files on the D drive. So what we're going to expect and see the logical capacity to be reduced by half. So I'm just going to go ahead, delete the files, yes, and we'll give it a couple of seconds, and what we're going to see is the bandwidth is going to increase because we're just going to invoke unmap on the XtremIO array. There you go. After a couple of seconds we can already see that the volume name is destination ODX, which is the volume that I deleted the files from, is starting to run an unmap process. You can see the bandwidth increasing, you can see the logical capacity decreasing. It should get to around 40 gig used, which is just about. And that's it. So after a couple of seconds the logical capacity has been reduced by half. Dedupe came back to 1 to 1 because that's just the unique files on the source volume. So that's it. That's the part where we integrate with Windows Unmap.